Hello everyone. Today we are going to present or see the topic about some of the special topics on magnetic materials. Is one of the special topic of the magnetic material that is called ferromagnetism. How it is ferromagnetism occurred in these materials. So now I am going to explain some of the basic concept of the ferromagnetic material. So you can see that is a ferromagnetic material exhibits a parallel alignment of a moment resulting in large net magnetism if and say absence of magnetic fields. These type of materials having the strong magnetic field in particular area. Dipole oriented due to the electronic convocation and dipole orientation, these materials have the permanent dipole moment. For example, nickel and cobalt, aluminium, nickel, ferrous and cobalt are the many alloys are typically classified as into the ferromagnetic material because it has the strong electromagnetic characterization. Another important characterization is two distinct characteristics of ferromagnetic ore. One is spontaneous magnetization and existence of magnetic ordering temperature. These are the two main categories of the ferromagnetic material. It will easily magnetize when it is kept on magnetic field. For example, you can see the pin and a magnetic magnet. Some of your speaker magnet you can take. For example, you can take the speaker magnet and the needle. You can place the needle into the magnetic lines of force, and the magnetic lines of force into the magnet. It will get magnetized after sometimes will be in the magnetic lines of area, forces area. So this is called as a magnetic lines of force. You can see that next it will be how it is magnetic field has been getting the magnetic field spontaneous magnetism occurs due to the domains of the magnetic domains. Domains is nothing but the that is the alignment of the dipole orientation in the materials separated by the walls, that is called as a wall the block, which is we can see the above images that is indicated that without a magnetic field H equals 0, that is that we applied if magnetic field is a 0, and that the dipole orientation also are different in different direction. When it applying the material placed, when we are applying the external magnetic field into that particular material, the orientation of a dipole orientation will be majorly will be aligned with this one applied magnetic field that will get the magnet converting the non-magnetic material to the magnetic material. So you can see that is the magnetic domains. Can see the magnetic domains of the material. Okay, magnetic domain will be you can see that magnetic domain is the state the material divided into number of small regions called domains. Each is spontaneously magnetized. You can see that is a another image of that magnetic alignment of the magnetic domain in the material. One is for facing the domains, electronic dipoles are domain facing one direction, another area electronic convocations, that is the dipoles orientation of the material will be aligned into another area. So it will be aligned when it placed on a magnetic field, that is with the magnetization process. Okay, that is the magnetization process into the mainly into the three category. One is unmagnetization random orientation of domains, and single domain process, domain wall rotation, and rotation of the domain along the field. These are the three steps of the magnetic magnetization process, which is converting a non-magnetic material into the magnetic material. Without field, you can see that images shows us without field there is a dipole orientation of the domains of dipole orientation. Every red arrow is indicated the domains of the magnetic materials. Magnetic materials. So it is domains without magnetic field. H is absence, H applied field is absence, that is external field absence. The rotation will be, the electronic domain will be separated by the distance. When you apply the electric field, apply the magnetic field, H is some values. So the weak field, which is the orientation of the molecule, orientation of the dipoles will be differed, and domains are different. When you apply the strong fields, the domains will be aligned with this applied magnetic field and directions. Okay, that was the magnetization process. First was it was explained by the domain theory, that is the movement of and rotation of the magnetic domains in a particular material is called as a explained by the domain theory of ferromagnetic materials. First one is there is 4 types of energy will be involved into magnetization process. One is exchange energy, second one is anisotropic energy, third one is the domain wall energy, then magnetic resistive energy. So in this class we have seen that what is the basics of the rotation. These are the basics of ferromagnetic material. So now the single domain will be large magnetic. This is the first energy, that is the rotation of and movement of the domain magnetism will be explained in the by the four types of energy transferring. That is a magnetization process involved in this three types of capturing four types of movements and rotation of domain walls in the magnetic material can be explained by the domain theory. So in this class I stop here from the as is axial energy, that is nothing but moment of the magnetic dipoles. In this next video we have clearly seen about that clearly seen about the moment of the dipole orientations and the moments of the rotations of dipole orientation and is discussed in deep in the next forthcoming classes. Thank you.